So let's go and look at some examples and look at in more detail regarding some calculations and ways of thinking about slopes of lines and line segments. So first we'll start off with the slope of the line segment connecting these 2 points. And we said we need to identify, well, we'll call them something, P and Q, I guess. And we have to say which point is coming first in our mind. So I'll go P1. So P is our first point. The coordinates are 1, 3. And Q is our second point. The coordinates are -5, -2. And then I want to compute the slope. There's 2 ways to think about it. One is the y2 minus y1, x2 minus x1. The other one is the change in y over change in x. Really measuring the same things. But you can see a change in y and a change in x without actually reading off coordinates if you just see points on the plane, if you wanted to. So considering that, we imagine as we move from this point to this point, the change in y is how much y changes. It starts at 3 and ends at -2. So 3, to get to -2, has to decrease by 5 units. So delta y looks like is -5. To get from 3 to -2, you have to decrease the 3 to get to 0 and 2 more to get to -2. That's a total of 5 units. As far as x is concerned, it starts at 1, ends at -5, so it has to decrease by 1 to get to 0, and then 5 more to get to -5. So that looks like it'd be -6. So the slope should be 5, 6. And we'll just check we get that. So we'll just put it here, I guess. y2 is -2, and y1 is 3, and x2 is -5, and x1 is 1. And sure enough, -5 over -6. So we got that right. For our second example, we're going to figure out the slope of the line 2x minus 4y is 12. The first way we're going to do that is by finding 2 points on the line. The easiest points might be the intercepts. The first one is x equal to 0, so that 2 times 0 is 0. Minus 4y is 12 is what's left. 4 times 3 is 12, but that's minus 4y, so we need 4 times -3 to be -12, and then that -12 becomes 12. So we'll put -3 here for y. And if we want y to be 0, then I got 2x equal to 12, so x is 6. Okay, and then we go ahead and compute the slope. Which one's the first? Oh, we'll just call this first point. This one's the second point. Okay. And then the slope is y2 minus y1, x2 minus x1. The choice of which point comes first and second doesn't matter. If you were to swap the roles of first and second point, you would change the signs of these quantities in the numerator and the denominator, but not change the size. So changing the signs of both keeps the same fraction. So either order, otherwise slope wouldn't be very useful, I guess. But it is important that you have whatever coordinate minus whatever coordinate imitated in the denominator. So if it's y2 minus 1, it has to be x2 minus x1. You can't just subtract any old way. y2 is 0, minus a -3 there, and x2 is 6. 0. We get 3, 6, which is 1/2. All right. Let's see. Oh, we're going to solve for y. So we're going to take this equation. 2x minus 4y is 12. And when we get done, I will show you what happens. So we'll solve that for y. So we get minus 4y is minus 2x plus 12. I just subtracted 2x from each side. And then we'll divide by minus 4. Y equals minus 2 over minus 4x plus 12 over minus 4, which is 1/2 x minus 3. So right here, slope is the coefficient of x let's see. But then, say, I think this pen is done. Okay. So once we solve for y, it says then the slope is the coefficient of x. So we look for the coefficient of x. Looking for the coefficient of color here. Right there, that 1/2. Since it's y equals, has to be y equals for that to happen. Y equals 1/2 x, the slope is 1/2. You might wonder about this other number over here, this minus 3. Well, that's the value for y when x is 0. X is 0 puts you on the y-axis. So that tells you the intercept. The y-intercept is 0 minus 3. So having solved for y, it has some use. Okay, where are we here? Okay, so we said we found this little line segment, just the old-fashioned thing, but maybe we didn't. Sometimes we just thought about how much x and y changed, as opposed to actually doing the subtraction to find it out. And then we found the slope of the line by finding 2 points on the line. You wouldn't have to pick the intercepts. They were just easy to find. And you could do delta y over delta x, but I actually subtracted them and got a half. And then we said, if you have a linear equation and you solve it for y, the slope then is the coefficient of x once it's solved for y. And we did that. Okay. So on to the next side of this. It says horizontal lines have slope 0. Why should they have slope 0? And that is because if it has slope 0, delta y is going to be 0 for any 2 points. I'm going to run out of ink if I don't watch out. Come back here. Hope there's some color in here. Vertical lines have no slope defined. Why? Because, this is better, delta x equals 0 for any 2 points. So you pick any 2 points. If it's a vertical line, the 2 points, the change in x is 0 as you travel between the points. Since you're dividing by delta x to get the slope, you can't divide by 0, so no slope is defined. That makes sense. Some interpretations of slope, we might have said this already, we certainly did it when we drew them, it's the change in y if delta x is 1. So if you have a line and it's the revenue versus number of items. So if we had revenue, dollars on this side, and here items sold, and here we go, like that. Then thinking about the change in y, the slope, being the change in y if delta x is 1. So that says if you sell one more item, the change in y, that's how much extra money you get for selling one more item. So if you hear somewhere here, and then you look over one unit to the right, the amount it goes up is the amount of money that you would obtain by selling one more item. So sometimes that's a useful measure of things. It's more useful if you're not looking at a straight line, thinking about how much does y change if you increase x by 1. Another interpretation, average rate of change. We'll do an average rate of change example at the end, having to do with driving your car and going at different speeds. And you'll see how the slope has to do with rate of change, and the slope of a segment, where the segment doesn't span a line, would indicate the average rate of change you'd have to complete the trip or whatever the situation is at a constant rate. We'll see that later. And then positive and negative slopes. So if you see a positive slope, what does that mean? It says, well, if delta x is positive, that means as you go from one point to the next, you're moving to the right. Then a positive slope says, as you go to right, you go up, because the change in y is also positive. So for a positive slope, if you look at the graph, the line rises to the right. So it rises to the right here. And if you have a negative slope, then if you go right, the change in y is negative, so the y's are getting smaller. So you have to go in a downward direction as you move to the right for a negative slope. So you can tell right off, if you see a line segment, whether the slope is positive or negative, just by imagining moving to the right along the line segment. If you go up, it's a positive slope. And if you go down, it's a negative slope. So that covers our more detailed discussion of slope, zero, undefined, slopes of lines in different ways, and another computation of slope of a line segment. And getting close to the end of the section, and I'll see you in a bit.